Hello, just want to talk about something interesting I came across while programming. Let me give you a brief overview of what I'm working on sometimes. There is this program called Anubis, is on GitHub, and people use this software to gate their website. It's like a catchpa, except for preventing bots from scraping your site or whatever. It does this by giving your browser a challenge, and it has to verify by solving the challenge. But it does this automatically. So I thought that was a neat idea, so I made Poor Man's Anubis. And the way it works is it generates a large number, and it also at the same time keeps track of what factors generate that number. And let me just show you what, let's see, factors. So let's see, a 10-digit number at least. It's probably not exactly, oh, it is 10 digits. Well, anyways, the factors are 5 and 13 and 1743 for this 10-digit number. And it's optimized so that it's actually base 64 encoded, and the format of the factors you're supposed to send as the client is like this. But the server's optimization is such that the result is actually hashed. So when the client sends this, the server hashes it, checks against the hash that was generated, and, well, if it matches, it's verified. And usually the server is set up to like generate about like, by default, 17,000 digits of number, and that is like 821 twos and 787 threes and all that. This base 64 encoded huge number that the client receives. It needs to make this string and send it back to the server, and if it matches the hash, then it's verified. And this took like at least a second to generate. So that's what the challenge is for my program. And that's kind of a sidetrack, because the thing I'm talking about, that I want to talk about, is actually a little bit different. Let me just show you. I have this part in my code where I want to listen on multiple ports for multiple sites you want to gate using this software. So if there's only one port you specify, it only serves on that one port. 2 ports here, and more is more generically done. And for example, I could serve on 3 different ports, 9001, 9002, 9003, and it would just serve that. So for example, if I want to serve these 4 sites, usually you want to serve to a local, like http://127001, whatever. But for the purpose of this test, I just did some sites of mine. And you can see this in action. Let's see, let me just do this side by side here. 9001, this is the challenge. It requires a challenge, the client gets the challenge. It sends it to the server. Once it's done, the server verifies it. The client knows it's verified because it got it okay. And now it's verified for 30 minutes. And 9001, port 9002, port 9003, and port 9004. Again, this is supposed to redirect to something locally, but for the purpose of this example test, it's these sites of mine. So the problem. This is very inefficient. This uses a procedural macro. And in Rust, a procedural macro is just, it's a way of doing things in compile time. Like instead of doing this hand by hand, let me show you for an example. Let me just, the problem, Butterfingers, the problem here, like, I have these addresses in a list, or a vector, or an iterator, or whatever, and I can make another listener by doing listener.join, and then another listener, new iter.next. Let's see, what's the problem here? So this is just another listener, but it has the type of JoinedListener, TcpListener, TcpListener, and you'd think you could just do something like make this thing mutable and then use a loop where for adder string in iter, do another listener equals listener.join TcpListener new the adder string. But there's a problem here. It won't let me. It says it's a mismatched type. The problem is this listener is already of a defined known type. It's a joined listener of two TCP listeners. And right here, this thing right here, if I did another let binding here, listener, this is a, oh boy. This is a joined listener of a joined listener of two TCP listeners and that third TCP listener. So it's a joined, and then these three TCP listeners, these, oops, wrong color, these three TCP listeners. So the type is different. If I do a join, it's going to be a join listener joining the join listeners of the TCP listeners. And Rust won't let you do this in a loop. I could just say, oh, let's just have, well, this is a joined listener of TCP listeners, and this is a joined listener of a joined listener, and you can see that this just won't work. So hence the procedural macro, and this is very, very not optimal. Let me show you why. This thing is kind of crazy. This thing accepts like 3 parts. Now let me open the thing again. It takes the iterator of adder strings. It takes one listener that I've already created and this router, so I can do this this server acceptor router at the end, because at some point it needs to take all these listeners that you've got and turn it into an acceptor by using bind on it, and then use that with the server and serve with the router so it knows where to route it to and await. So since it took the iterator of adder strings, the listener, and the router at the end. So how it works is it takes that, and eventually it keeps track of how many times this thing is recursively nested, because it does this by recursion. And recursion basically means calling the function by a function it calls itself. And the first time you call it, it says idx to 0 because it's the first time. And it says, oh wait, it's not greater than 32. Let's just create a text that says a joined listener joined by the listener passed to it and the next value in the iterator. And then call this macro again. And this is only if there are more items in the iterator of adder strings. And if the iterator is empty, then it branches to the server new listener bind await and then serve router await. So as you can see here, the more adder strings there are in the iterator, the more times this thing calls itself to constantly make a new let joined and then combine and all that. And it's kind of crazy because it does this up to 32 times, and I have had to add this extra thing in main, Recursion Limit 256, because if I remove this, it's going to complain that it reached the recursion limit because this procedure macro calls itself, and I'll explain it. Like, I'll have to show you how bad this is. Cargo build. The debug build. Let's see how big this debug build is. It's about, well, with everything, 235 megabytes. But I mean, release build, you have to go my word for it. It's about 20 megabytes. Let me just show you what I mean when I remove this procedural macro call and then build it again. and it has a bunch of warnings and all that, but this time it's 128 megabytes, half the size of the debug build. The release build, last I checked, was with the procedural macro running, it's 20 megabytes. Without it, about 17 megabytes. So this procedure macro, while it does handle up to 32 recursive calls of itself, joining like up to 32 different addresses, it has to know all this at compile time, because this join thing, again, is its own separate type. You can't do this in a loop. You have to, I had to literally generate a recursive macro. All of it compile time. Ridiculously large size of 235 in debug. It's crazy. So, yeah. The fix is much nicer. Much nicer. Sorry for the jump cut, had to wait for this to build. Anyway, the fix that I made for this, I removed the procedural macro, as you can see here. And instead of doing a procedural macro, when there's at least 3 adder strings, I used a wrapper around a vector, and I mean, you might be thinking, duh, I should have used a wrapper in the first place. But let me tell you, it was a little bit difficult. It was a little bit difficult. Let me show you why. This TcpListener, you have to, basically the trait has to be implemented by the listener trait. Try bind, you have to implement this thing, and you're thinking, that should be easy, you just have to implement traits, right? Well, at first it looks easy. I mean, I just make this wrapper struct that has a vector of TCP listeners. I push listeners onto it with this push function. When you run bind on the listener, which is what happens internally, it makes an acceptor, and an acceptor has to implement acceptor. It sounds, okay, that also sounds dumb, but look, I had to keep track of a vec of holdings for all the TCP listeners, which is done by calling this finalize holding, which is done at the end of adding all the listeners to the listener, vector listener, and collecting all the holdings of each listener, acceptor, whatever. Yes, but it also needs to be able to accept. So basically I was an idiot. I could do everything with an iterator. I mean, if you look at how TCP listener does stuff, this join listener that it has, it's the handy thing about open source. You get to see the source of the stuff you're using that's open source. Tokio select on each acceptor that are joined by the joined acceptor, which is created by the joined listener on 2 TCP listeners, whatever. Anyways, yeah, equivalent of Tokio select. I can't use Tokio select because it's a vector of acceptors, listeners that turn into acceptors. And the nice thing about futures, there's this iterator struct, FuturesUnordered, which can be created from an iterator of futures. And that is what I did. I made an iterator of my acceptors, TcpAcceptors. I did accept on each of these with the fuse factory cloned, which is the parameter to accept, by using iter map on each one. And this iterator was put into this FuturesUnordered from iterator. And all this used something called try-ready trunks. And if I just show you the quick adapter for chunking up ready items, so capacity, the amount that it checks that is ready, and I just need to get 1. It should be the same behavior as this Tokio select on each of these. In this case, for the join listener, it's on the 2 things that it's joined. And in my procedure macro, you would know that since it was recursive, it would be tokio select. Inside of that, a join acceptor, tokio select, crazy nested recursive stuff. But just using this try ready trunks with one to get that one I need that's ready, that has accepted, which means, well, I looked into it. It's just basically these TCP acceptors are binded to like 127.0.0.1, port 9000, whatever. And when you call accept on it, it tells it to wait for a connection to 127.0.0.1, port 9001 or whatever. And once that connection comes through, accept returns success, otherwise it blocks. That's basically how this works. And the moment one thing in this iterator is ready, which is what this one is for that one, it gets it and returns it in this accept. And because this FuturesUnordered is so nice, I can just get that one that's ready, that binded, and just do some error handling here and return the binded accepted TCP acceptor, this connection, and it just works. The salvo, the thing I've been using here, salvo basically does most of the heavy lifting. So yeah, so I was an idiot. I used a procedure macro to do everything compile time and significantly increase the size of the binary, where it should have been much, much more lenient by using an iterator handling kind of stuff. As you can see here, this is like right now 130 megabytes, which is not that much bigger than that previous value. It's not as bloated as 250 megabytes. And let me tell you, release build, it's about like, let me just build it, whatever. Jump cut to after I finished building it. The release build is 16 megabytes. And if I just go back to build that had the procedural macro, let me build this in release mode. Jump cut here, let's see, with the procedural macro release build, the size is 20 megabytes. Previously it was 16 with the vector iterator fix. Now with the procedure macro it's 20 megabytes, like 80% basically. Debug build 250, debug build without procedure macro 150-ish. You get the idea. Basically, needing to know everything compile time with the recursive function calls, it just increases the amount of code in the executable. It increases the amount of instructions in the binary to execute. Just so, yeah, I was an idiot. I should just use used the handy stuff that's available in the Futures crate, the Tokio crate, instead of just using a procedure macro to just do everything compile time up to 32 times even. And that was only up to 32 calls of joined iterator. If I had done like 64 or 128, that thing would have exploded to really astronomically large compile times and, well, not compile times, but recursive calls that just, not good. Why do everything like that as if you're doing it by hand, but with a macro, when you can just use a vector and iterator helper functions? That's basically it. So, thanks for listening. I hope that interested you. I hope that was interesting, I mean. That was weird. Anyway, yeah, that's it. Thanks for watching.